Hello everyone, this is grade 6, module 6, lesson 12, problem set. Number 1 says, the amount of precipitation in each of the western states in the United States is given in the table as well as the dot plot. So we can see that we have the states over there with the amount of precipitation, in inches. A says, how do the amounts vary across the states? There's a lot of things you could say in this one. The first thing I want to figure out is the spread. So that'll tell me a little bit. I see that I have 63 and 7/10 inches for Hawaii, and Nevada is 9 and 5/10. So if I subtract those two, I'm going to end up with 54 and 2/10. So that tells me quite a bit that the spread is very large. Nevada has the lowest at 9 and 5/10. Hawaii has the highest at 63 and 7/10 per year. If I look at who has the most here, Hawaii, I have Alaska, and I have Washington. And right now I'm really just summarizing the data to show you that we're kind of showing the vary across the different states. We have some that are low, with the lowest being Nevada. And the second most is going to be right here with Utah. So down below, we'll take a look at B. Find the median. What does the median tell you about the amount of precipitation? So the median means I have to put all of these numbers in order from least to greatest. And then I'm going to cross off to find out which one falls into the middle. So I'm going to put these in order from least to greatest right now. So there's my numbers in order. And now what I got to do is cross off from the outside. So I'm working my way to the middle. And what I'm trying to do is get down to the last values, and I see I have 1, 2, 3, 4, 5, 6 cross-offs on one side and 1, 2, 3, 4, 5, 6 on the other, meaning my median or middle number is 15 and 9/10. So the mean, it says for B, find the median. What does the median tell you about the amount of precipitation? And it tells me that from the values of 63.7 to 9.5 inches per year, half of the states have from 9 and 5/10 to 15 and 9/10, and that the other half are going to be above, and that we only really have 2 states right here that are more than 40. And that's just kind of summarizing the data and what it's telling me. But it is telling me that half of the states are 15 and 9/10 or below. So the last part, C, says, do you think the mean or median would be a better description of the typical amount of precipitation? So what you're going to have to do now, and I'm not going to actually solve this one, you got to find the mean. So you got to add all of these pieces of data up and divide by 13. And that'll get you the mean. And then your median is right here. And then what do you think would be a better description of the data based around that? Keep in mind that the mean is going to reflect those extreme values, meaning the high ones in this case and the very low ones, which aren't really that far off, but the real high ones. So it's taking into account those, where the median is kind of crossing those out and working towards the center of the data. So keep that in mind when you do it. But let's take a look at page 2. And here we are on page 2, and we're going to zoom in and take a look. And we have to identify the following as true or false. If a statement is false, give an example showing why. So we're on A, and it says the median is always equal to one of the values in the data set. And that's false, because what if I cross down and I'm left with 2 numbers? What if I have 2 pieces of data like 1 and 5? Well, if I cross those off, really I have to find the average or the mean of those two, and my median would be 3. And that's not one of my pieces of data. So if I have two pieces of data with a value of 1 and 5, the median is going to be 3. So I just gave you an example of how the median is not always a piece of data. So let's take a look at B, and I'm not going to go as in-depth on these explanations, but I'll help you get at least a start whether you need to find an example or not. So B says the median is halfway between the least and greatest values of the data set. That's false. When you find the mean of the least and greatest, that's going to get you halfway, but the median is not always halfway, and that's actually what we can look at from the problem we just did when we had Hawaii and Nevada. Hawaii was 63 inches or so, a little bit over that, and I'm just kind of guessing the numbers here because I don't have them in front of me. And Utah or Nevada was 9 5/10. So halfway between that, we'll just say 9 and 63. So if I add those, that's 72. That'd be 36. That's halfway between those two numbers. But our median was 15.6, I believe, or right around 15. I'm just guessing on the numbers here. But that's not halfway. So that's an example of what we just did, and you can use that example from the first page. C says, at most, half of the values in a data set have values less than the median. That's actually true, because half should be on one side of the median, half should be on the other side. So half are going to be less than the median, half are going to be greater or at the median. In a data set with 25 values, if you change the two smallest values in the data set to smaller values, the median will not change. That's true, because remember, whether we have as these two small pieces of data as 1 and 1, if I change these to 2s, they're still going to get crossed off, and I'm still going to get the same median. And this even said to smaller values. So instead of changing them to 2s, what if I put them as 0s? They're still going to get crossed off. E, if you add 10 to every value in a data set, the median will not change. That's false. If every value goes up by 10, the median goes up by 10. And you can show a quick example for that one, like if you use data set 1, 2, 3, 4, 5. And I know that my median is 3, but if I change it to 11, 12, 13, 14, and 15, my median is 13, so it goes up by 10. So here we are at 3, and it says make up a data set such that the following is true. The data set has 11 different values, and the median is 5. So different values, meaning I can't have the same values for all of them, so I couldn't do all 5s. So I want my middle number to be 5. So if I take 1 away from it, it means I have 10 left, because I just put 1 in, and I need 11. So there's 10 values I have left. I know with the median, I have to have an equal number on each side. Half are going to be below and half are going to be above. So I need to do 5 numbers less than 5. So I can do 4, 3, 2, 1, and 0. That works out good. And if I didn't have room, I could have put in 2 1s or 2 2s. And now I just need to get 5 more values above or at. So I'll just go up this way. So again, there's going to be half of the data set that is at or below the median, and half that will be at or above the median. Right now it's at 5, and I have 11 different values. And you can obviously have something different. I'm just giving you examples. Now the data set has 10 values, and the median is 25. I'm going to take the easiest way out, which you shouldn't do, but I will. 10 values, it doesn't say different values. So all my values are going to be 25. So the median has to be 25. That means the mean is going to be 25. That means my mean absolute deviation is going to be 0. Easy enough for me to figure this out. So that's my easiest data point right there, is that all of them are going to be 25. Now for C, it says the data set has 7 values and the median is the same as the least value. So again, I don't know. You could put all the same and say, well, the least value and the highest value are the same. But if I have 7, it means I'm going to have I know what the fourth value is going to be my median, because that gives me 3 on each side. So 3 here, and then another 3 over here, and this is going to be my median. So I can put whatever I want over here, but I know that my median of 1 is the same as my lowest value. So this first number has to be the same as the fourth number. Let's take a look down at question 4, and it says the dot plot shows the number of landline phones that a sample of people have in their homes. How many people were in the sample? So to answer that question, I'm going to count all of these little dots. So you can go through and do that. That's easy enough. B says, why do you think 3 people have no landline phones at their homes? This could be, you could have a couple different answers for this one. My one that I'll say is, why do I think 3 people have no landlines? They have cells. Or cell phones. Because that's a realistic thing now, that if you have cell phones and you get great service, you don't need a landline. So that's one possibility. C says, find the median number of phones for the people in the sample. This is where it gets a little interesting, because what I have to do right now is I got to put down all of these values. And it's not just 0 through 8. It's 3 zeros, because there's 3 dots above. And then there's 1, 2, 3, 4, 5, 6 above 1. So I have to have 6 ones. And then there's 5 twos. And then there's 4 threes. So I could keep listing like this. Or I could start crossing off dots. Or I can count how many total there are. And I can figure out where my halfway point is. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25 total. And that answers A, even though I told you you could do it. And I know that I'm going to cross off 12 on each side to get to my 13th value. So I want to split this up evenly. I know I can do 12 and 12, and then 1 in the middle. And I know that might be difficult to do, but if you cross off on the outsides, like 1, 8, 1, 0, that's where you can kind of figure out where your middle number is. But what I'm going to do is take what I know about these, and I'm going to find my middle value. And I got to go to 13. Because the 13th value, in order from least to greatest, will be my median. So there's 3, 2, 4, 6, that's 9, 10, 11, 12, 13. So it's going to be 2. My median is going to be 2. So that's what the median set for these is. Thanks for watching. Hope this helps, and good luck on the rest of your problem set.